All right, I want to go over 5 problems from the book that you can use as a guide to see whether or not you understand the information for the test that you're going to have. I'm going to go over page 388, numbers 9, 13, and 19. I'm going to go over page 395, number 40, and number 50. Now, this review does not include graphing, so you're going to have to figure that one out. 388, number 9, it says simplify each expression. You're given 3 to the 1/4 times 27 to the 1/4. When you rewrite that in radical form, the 4, which is the denominator of the exponent, becomes the index, and the 1, which is the numerator for the exponent, you're going to make that your exponent for what's underneath the radicand, or what's underneath the radical sign, which is the radicand. So you have the 4th root of 3 to the 1. You don't have to write the 1 in. Same thing for the 27. The 27 to the 1/4, when you write it in radical form, is the 4th root of 27 to the 1, or just the 4th root of 27. So since they're both to the 4th root, if you have the 4th root of something times the 4th root of something else, you can write that as the 4th root of whatever times whatever. In this case, the 4th root of 3 times the 4th root of 27 is the 4th root of 3 times 27, which becomes the 4th root of 81. Now, when you factor 81 down into its prime factors, you get the 4th root of 3 times 3 times 3 times 3. Since the index is 4, you're going to take groups of 4 outside the radical sign, with one representative being written down. So the 4th root of 3 times 3 times 3 times 3 becomes simply 3, because you took 4 of the 3's and brought them out and wrote down one representative. Moving on to number 38, page 388, number 13. Very simple. Write each expression in radical form. If you're given y to the 2/5, the numerator for the exponent is what becomes your exponent underneath the radical sign, and the denominator for the exponent becomes your index. So y to the 2/5, the 5 is your index, the 2 is your exponent, you get the 5th root of y squared. For page 388, number 19, it says write each expression in exponential form. You have a radical sign 7x cubed. Now, when you don't have any index written down, you can assume, as I wrote there, that the index is 2. And what you're going to do for each of the factors in there, you have 7 as a factor and you have x cubed as a factor. You're going to make sure that they have an exponent. So that's 7 to the 1 times x to the 3. So then what you do is you bring each factor out and you give it its own exponent in fractional form. So that becomes the square root of 7 to the 1st times x to the 3rd. You now have a factor of 7 with an exponent of 1 divided by the index of 2. For x, you have x with an exponent of 3 divided by the index of 2. So it's 7 to the 1/2 times x to the 3/2. 395, number 40, it says solve and check for extraneous solutions. I made certain assumptions when I did this that you understand the algebraic steps. It's 2 times the quantity x minus 1 to the 4/3 power plus 4 equals 36. The first thing you need to do is isolate what will be your radical. So, and it can also be you isolate any factor that you have raised to an exponent, to a fractional exponent. So we have 2 times the quantity x minus 1 to the 4/3 equals 32. What I did was I simply subtracted 4 from both sides. Then I'm going to divide both sides by 2 so that you'll have x minus 1 to the 4/3 equals 16. X minus 1 to the 4/3 is isolated now. What we're going to do to make it so that you don't have a fractional exponent is you're going to multiply, or you're going to raise both sides to the power of the inverse of 4/3, which is 3/4, or the reciprocal. So x minus 1 to the 4/3 all to the 3/4, because when you raise a power to a power, you multiply your exponents, and 4/3 times 3/4 is 1. X minus 1 to the 1st power is simply x minus 1. That's the whole reason you do this. And that equals 16 to the 3/4. You can rewrite 16 to the 3/4 in radical form, and you get x minus 1 equals the 4th root, because 4 is the denominator of the exponent, the 4th root of 16 to the 3rd power, because 3 is the numerator for the exponent, and that becomes the exponent underneath the radical sign. When you take the 4th root of 16, you get positive or negative 2. When you cube positive or negative 2, you get positive or negative 8. So on the right side, you'll get positive and negative 8, and on the left side, x minus 1 remains x minus 1. Then what we do is we write it out as two equations, x minus 1 equals positive 8, or x minus 1 equals negative 8. When we add 1 to both sides in either equation, you'll end up with x equals 9 or x equals negative 7. You check for extraneous solutions. I'm not going to do it right now. You'll find that there are none. Page 395, number 50. You're given the problem 2x minus 1 to the 1/3 equals x plus 1 to the 1/6. What you need to do is you need to raise both sides to the power of the common denominator of the two fractions. The common denominator of 3 and 6 is 6, so you're going to raise the left side to the 6th power, you're going to raise the right side to the 6th power. When you raise a power to a power, you multiply, so 1/3 times 6 is 2. That's your new exponent for the right side, so you have 2x minus 1 to the 2nd power. 1/6 times 6 is 1, so you get x plus 1 to the 1st power on the right side, or simply x plus 1. So you have 2x minus 1 squared equals x plus 1. Now we're going to distribute 2x minus 1 times 2x minus 1. I can't say the word FOIL, but we're going to distribute. We get 4x squared minus 4x plus 1. You can, if you're not sure how to do that, ask me or ask Mr. Albanese later. Equals x plus 1. We're going to subtract x from both sides. We're going to subtract 1 from both sides. We're going to get 4x squared minus 5x equals 0. Factor that to x times 4x minus 5 equals 0. You now have two equations, either x equals 0 or 4x minus 5 equals 0. After you solve for x, you get x equals 0 or x equals 5/4. Then you're going to check for extraneous solutions. When you substitute 0 in, you get negative 1 to the 1/3 power equals 1 to the 1/6 power. That doesn't check out. The math does not work out because negative 1 to the 1/3 power is negative 1 and 1 to the 1/6 power is positive 1. That's an extraneous solution. 5/4. I'm not going to do all the math out. When you substitute it into both sides, the right side equals to the left side, so that is not extraneous. Awesome. If you have any questions, let me know.